camera. So this is a square. Is it cool if I say that? It's like saying 9 is a square, right? Because 9 is 3 squared. So this is something squared. It is a square. So I'm starting backwards. Completing the square is trying to add something in to make it become this. So if I break this up, if I FOIL this out, what do I get?
X plus 4 or X squared.
Oh, okay, sure. You didn't write it twice. Can you guys, you get to the point where you can do this in your head. It's got to be this next to itself. X squared plus 4x, right? Plus 8x
Plus
16. All right, let's do another one. X minus 7 squared. What would that be?
X squared minus 14x.
Minus 14x, right? 7, 14? Plus 49. I love it. Amazing. Okay, I could keep going all day and go a little insane, but what's always happening? Isn't 16 this number squared? Isn't 8 twice this number, right? Negative 14 is twice this number. 49 is that number squared. It's always going to be that way. Of course it is, because that's how I got the middle term, 4x, negative 7x, negative 7x. So what do I get if I do x minus a squared? Oh shit, maybe I should write this one out. What do I get? X squared
Minus a minus
2x
minus 2ax
a squared.
plus a squared. So it's always twice that number, and this last one is always the square of that number. All right, always. Always, right? No matter what I write down. So, completing the square is thinking backwards about that. What completing the square says is, if somebody gives me this, I want to figure out what do I add to it, so I would complete it so I can write it like something squared. So again, where did that middle number always come from? It came from...
25.
Where'd that middle number always come from? It came from
4.
twice this. Didn't come from 4. 8 came from twice 4. Negative 14 came from twice negative 7, right? So how do I figure out what number this is? I just take this, cut it in half. I love it. You guys see that? So one level of math, it's not even freaking math. It's just like, well, that always happens, so I'm going to do this. Holy shit. Yes? So I can always find this number if somebody tells me this number. Is that cool? I could also do it if they told me that number too, couldn't I? But that's not going to be what this is. It's not, that actually wouldn't make any sense in the context of the problems, but I could if they wanted me to, right? I just square root it. So the first step is to cut the middle number in half. That's the number that goes here. Now what number has to go here? Now we're catching up with Nathan. I take that number and do what with it? Square it to see what number goes there. So that's the number that I need to add to this to make this work. That's why it's called completing the square. What do I have to add to this problem so that I can write it as a square? Completing the square. Good job, math people. Appropriate name. I like it. Let's do another one. First step. So where's that go? It goes inside. It tells me what goes in here. Now I got to figure out what to add here to make that true.
16.
Yeah, you take whatever you got and you square it. So that's what I have to add to make it true. All right, so now a really good question would be, what the hell use is this, Jeff? All right, so you're like, assume I always have that question, Jeff, and it'll be a lot quicker. I see on some of your faces. I love it. You're like, yes. All right. So How do I solve this equation?
Get 16 to the other side.
You could, but real quick, the only way we know how currently
Difference in squares and then.
factor it. Yeah, there's 16.
We can complete the square.
No, we can't.
And then X.
Sorry, buddy.
And then just.
We don't have to because we don't have an x term. Yeah. So you got x equals 4, negative 4. So we're going to leave that in the past. I like that you said add 16 because that's what we should do now. If there's no x term, there's no real need to do this. But remember, how many answers are there?
2.
There are 2 real answers. In fact, we're going to get complex answers here now, too. Oh, shit. So if I do add 16, what do I do to both sides?
Square.
Now here's where you got to make this second nature. How many answers should there be?
2.
How many roots of 16 are there? 2. There's a positive one and a negative one. So if you're taking the square root, you better put a plus or minus there. Because you got to get both answers. That's different from this. Don't tell me that this equals plus or minus 4. That's crap. The square root of 16 is 4. But if the question is, what do I square to get 16? There are 2 answers. I'm taking the square root. So I have to give both roots, the positive root and the negative root. Yes, sir.
So it's like a principal square root.
Good. That's the principal square root. I love it. Which is defined to be the positive root. There's 2 roots. So I get x equals plus or minus 4. The same answer I got there, arguably a little quicker. Yes, no, maybe so? And of course, I could do that same thing with things I could never factor the same way we did. I'm building my way up to this completing the square, by the way. So for example, if I had x squared minus 11, can you factor this? Not really, right? But I can just
Move 11 over.
add 11,
Square both sides.
square root.
You get plus or
Good.
minus.
Make that an automatic. When you take a square root, you put plus or minus. It's an automatic thing. It's got to become just second nature. It should feel wrong if you don't do it. So x equals plus or minus, right? 11. I just can't do the square root, so oh well. What about this one?
Would you put rad 9 or rad 9 rad 3 rad 2, or would you just put rad 11?
Well, you don't multiply to get 11. You have to make factors of 11 that you could pull apart.
Oh, you
And 11's prime. So I know what you're doing, 9 and 2, but you have to add those. So the radical could never work with those. So 11's prime, so I know I can just stop there. All right. This one. Yeah, again, the process doesn't give a shit that it's negative. The process says kill the square, plus or minus. So you get x equals
Plus or minus 5.
5 I. Square root of 25 is 5. You better not tell me square root of negative 25 is also 5. That doesn't make any sense. Square root of negative 25 is 5i. So you will get complex answers from now on. When? Any damn time that they happen to be the answer.
But isn't 5i also the same thing as plus or minus?
No, definitely not.
Squared is negative.
I is the positive root of negative 1.
Okay.
So I'm picking up both the positive and the negative. Yes?
But why in the first one you didn't put 4 instead of 4? Down. I'm going to say this one.
What about it?
You put 4 and the second you put 4, right? 5, right?
All right. What's the square root of 25?
5.
5. What's the square root of negative 25? It can't also be 5. It's 5i. Because I can break this up as that. That's defined to be I. So anytime I see a negative in a radical, I can represent it as I. So if the square root of 9 is 3, the square root of negative 9 is 3i. It's that simple. If you see a negative inside, I put an I on what I normally would have put. Right? Not the googly eyes. Yes, sir?
This will work in squares and fourths. Will it work in
We're going to stick with squares because the higher level roots get weird with complex numbers. When we do it like this, when we start talking about something that you all should probably have heard of, a quadratic formula, That's where we're going to get like the complex answers for x cubed equation, right? So it's really, if I have x cubed equals 64, there's no good direct way to get the other answers. There are two other answers. Can you see them? No, because we've actually written, the minute I do the cube root like this, I've picked the real one. I've already picked an answer. I've lost the other two. So we're working our way up, working our way up to being able to do this problem. And it's going to use a quadratic formula to do it. So some of you guys, I really hope you realize a cube means 3 answers. If you do this before today, you're right. Because I only worried about real answers before today. But that should have somebody should have been like, he said there's supposed to be 3 answers? This jackass, does he know what he's talking about? Yes, I do. We just haven't been able to, before today, get the other 2 because they're complex answers. Okay, I like it. It doesn't make them any less real. It just makes them weirder. That's all. Okay.
This is I negative, or 4i and negative 4i?
Where are we looking? Sorry. Here? No. Because it's a cube root. That's what my point was. Square roots are what i's are built on. So how do cube roots work? Not directly. I can't do them directly because i's are based on square roots of negative 1, right? Okay. That's a good answer. A good question. But that's really the quick answer. Why not? All right, so what about this? I don't know what number I'm on, but please realize this is nothing different. Let me make it a little, well, let's start nice, Jeff. Sure. Do you guys realize this is not different from the last one we did? What do I need to get rid of? Where's my variable expression? Is it stuck inside something? Do you see what I mean when I say that? I see a x plus 5. Where is it? It's stuck inside of a square. Okay, shit, I got to break that wall. How do I kill a square? Square root. So please don't foil this thing out. You're not wrong, you're just not doing it the new way, and you're taking longer than you should. Right? I can attack this thing directly, because I can take a square root, which means I better put plus or minus. Good. So you get x plus 5 equals plus or minus 3. So x equals negative 5 plus or minus 3. Now please, dear God, don't circle that. And please don't ask me where your plus or minus button is in your calculator. That's telling you to do 2 things, right? One answer is negative 5 plus 3, and the other answer is negative 5 minus 3. It's telling you both answers at once. So you just pull it back apart. Especially when it's like terms, you can put them together. Negative 5 plus 3. Negative 5 minus 3. Yeah, now you can check it. Nice thing is, you can check it to make sure the answer is right. None of them are going to make the problem undefined or something, because I'm squaring, not square rooting, right? I can square anything I want to, but I can't square root anything I want to and have it come out real, right? Yeah, you can plug it in to see if it works. Negative 2 plus 5 is 3 squared is 9. Negative 8 plus 5 is negative 3 squared is 9. So it picked up both sides. What do I square to get 9? 3 or negative 3, and that's what those 2 do. Then you get 3 and negative 3 inside. All right. You guys are dragging a little bit. I just want to stay with me.
So every time you square one side or both sides of an equation, you have to throw a plus minus in there?
Yeah, when you square root, you got to get both roots. When a square root's just sitting there looking at me, somebody's already picked which one they want.
Guys, it's still going.
You don't, yeah. Nobody in here wants me to dance. Nobody wants that to happen. Or, whatever you call it, what I do. All right.
So you square root it, plus minus.
Yes, I love it. Exactly. Kick ass. Okay. The higher roots, you can't do something like that, which is sort of related to your earlier question. All right, wait a minute. Oh. Okay. So, finally, let me make this connection with the completing the square thing, and then we'll take a break. So you see, this problem was relatively easy because it started off like this. That was where this problem started off. You guys understand what I'm saying? Why was it easy then? Because it was already all collected. This side was already a square. So if it isn't already a square, I can use completing the square, holy shit, to make it look like this and then to do that. So what do I mean? I don't know what I mean. Sure. Now notice, if you subtract 7 over, like you should do maybe before today, could you factor what you get? Can you factor x squared minus 5x minus 7? No. So that doesn't lead to shit. So let's not do that. Oh, well, let's see if you guys can handle this. I made it a little bit uglier than I wanted to, but I don't care. It's going to be some fractions, right? The process doesn't care. We care a little bit. So what's the process say? You see how I left myself some room? Because I want to figure out what to add here so I can make this become something squared. Okay, right? That's the idea. Because then I can just take square roots plus or minus and do it from there. And then it's relatively easy after that. So how do I figure out what to put there? What are the 2 steps?
Divide 5.5.
Yeah, cut negative 5 in half, and I get negative 5 over 2. And then what do I do with that?
Square.
Square. What do you get when you square that?
25 over 4.
4. So that is what I have to add. So now if I add it here, a little bit different than what I was doing earlier. It wasn't an equation I was doing earlier. It was just making the 2 sides agree. Now I've added something to this side. What do I have to do? Better freaking add it to the other side, right? Don't. Just because I got that number in a weird way doesn't suddenly make me able to break the rules of equations. If I add something to one side, I better add the same damn thing to the other side. Yes, sir?
Do we now subtract it from both sides?
And then I get right back to where I was. So it didn't help me. So I don't want to lose it, because now this looks disgusting, right? If I said factor this on a test, you could get up and slap me, maybe. It's almost to that level. You can get up and go like that and then not. Right? But you can show your anger. But you're not totally alone. What does this part tell me? This part tells me what to add. This part tells me what the freaking answer is going to be. I don't have to think at all about this. X minus 5/2. Because that's what the first step was. I don't know if you guys remember that. The first step always tells me what's inside here. I do have a handout I'm going to give you in a minute that has all these steps on it. Just to augment your notes. What's on the other side?
7, 25
We can do better than that.
Yes, sir.
28.
Yeah, 7 times 4, 28 plus 25.
53.
Stay with me now. Now, I know it's got a fraction in it. I don't care. But it looks just like this did. Something squared equals something. So what do I do to both sides? Square root. So once I complete the square, what was the whole reason I did it? So that I can just directly square root it away. Thank you. So now we are doing exactly what we did here. We just didn't start with a nice thing, so we had to make it using completing the square. I had to make it into a nice form. Once we get it in a nice form, we're going to attack it. I'll do this side. Well, that side's not hard, right? What's the square root of 53? I don't know. What's the square root of 4? So you do the part you can, and you don't do the part you can't. That sounds familiar.
So James, the question starts with x squared minus 5x equal to 7, and we add 25 over 4.
Yes.
Because
Cool.
why we add it? Because it's like
Because
prime or something.
adding 25 over 4 allowed me to factor this as something squared.
So the next step to add 25 over 4.
And since I did it here, I have to do it there. That allows me to factor it like this, squared. So then a square root applied will kill it. And then I can just solve for x. So one last step. Why is the x not by itself?
Add 5.5.
Yeah, add 5/2. So I get x equals 5/2. It's almost nice when this is ugly, because can I put those together?
No.
Not really. They're not like terms. So screw them. They stay like that. All right, let's take a much-deserved break. Be back at 5 till. Oh, real quick, let me give you this